Okay, so let's look at some of the other trends that we have to know. So metallic characteristics decrease across the period, right? Metallic characteristics refer to the ease of the atom losing the valence electrons to form cations. So across the period, you should know it goes from metal to non-metal, right? So metal will tend to lose the electrons and your non-metal will gain, okay? Then we have what we call the first ionization energy, right? First ionization energy refers to the energy required to lose the first electrons. Okay, so first ionization energy will increase across the period. Okay, why will it increase across the period? This is because as we go across the period, the number of protons in the nucleus increases across the period. Okay, however, the number of electron shells remain the same. Stronger electrostatic force of attraction between the delocalized electrons and the positive proton nuclear charge, leading to a decrease in atomic radius. So there is stronger electrostatic force of attraction. Therefore, first ionization energy, which is energy required to lose this valence electron, increases because stronger attraction force. Okay, electronegativity increases across the period. Okay, what is electronegativity? This refers to ability to attract the electron. So again, we know that my non-metals will gain, right? Since the attraction force is stronger as we go across, right? So from losing electrons, now the electrons are attracted, and then the electronegativity will increase. Okay, so generally speaking, this is the trend, this is the trend, and this is the trend. All three trends will attribute to this reason. Okay, even though I mark IP over here, this part, right, sometimes it can appear in the database question. Okay, so just now on top we are looking at atomic radius. Now we are looking at ionic radius. So radius of the ions. Okay, radius of the ions will decrease for metals. Okay, so what happens is that electrons are removed from the valence shells of metals, and then there is increasing nuclear charge. Therefore, ionic radius for metals will decrease, right? So example over here, my metal, my lithium. Lithium forms Li plus, right? So when it loses the electron, okay, the atom itself, the radius, there's two shell, but once it becomes the ion, when it loses the electron, there is only one shell, so the radius becomes smaller. And then if I compare lithium to beryllium, lithium to beryllium to boron, okay, what is going to happen is that across the period there's increased nuclear charge, right? Again, this is because there's increasing protons, so it gets smaller and smaller, so the ionic radius gets smaller and smaller. Okay, what happens for my non-metals? Non-metals, the ionic radius will increase across the period. Okay, so what's going to happen? Electrons are added to the outer shell to form negative ions. So 2, 5 will actually become N3 minus, right? 3 electrons are added in. Okay, and then this one will become O2 minus, where 2 electrons are added in. And then this one will become 1 electron added in to get my F minus. Okay, so electrons are added into the valence shell, and then what will happen is there is what we call higher shielding effect. There's higher inner repulsion. Okay, so what's going to happen is, right, I'm trying to add electrons into the shell where there's 5 electrons. So 3 minus and 5 negative, 5 minus, right? They have a repulsion because minus and minus, they will repel. Okay, but when I try to add 2 into 6, okay, 6 has more electrons, right? And as well as when I'm trying to add it into 7 with my fluorine, this one has more electrons. So they lead to higher shielding effect or repulsion. So it is harder to add the electrons. So when it is harder to add, the size will increase. Okay, because of this repulsion, it also pushes and the size of the ions will increase across the period.